Now let's look at motors and motor control circuits. And when we talk about motors, we are talking about three-phase motors like you would find in an industrial setting. It could be a motor running big equipment. It could be an automation circuit. But whatever, if you're an electrician, you will be reading diagrams like these. This is called a ladder diagram. And if you are a drafter, you will be drawing ladder diagrams like these. And they're all organized basically the same. We're going to try and take small steps at a time and go through how they work. When we think about a circuit contains basic parts, no matter how big nor how small it is. There will be a power source, and in this example here, the power source is a DC battery. In your manufacturing facility, it might be the line voltage coming in at the meter. Then there will be a load, and the load uses power, so in this case it's a light bulb. In your plant, the load would be a motor. Then there's a control device of some sort, a way to turn on and turn off the power, usually a switch of some kind. They're all connected with wires, conductors, plus there's some kind of protection device, and you're probably familiar with fuses and breakers. Down in the lower right corner of this slide is a part of a ladder diagram. This is this circuit that we've been looking at expressed as a ladder diagram, and it's called that because the vertical power lines look like the legs of a ladder, and then all of the control devices are on horizontal lines that look like rungs of a ladder. When we're in a shop setting or a commercial industrial setting, the power source is usually 3 phases of power coming in on 3 lines, which you are familiar with, and our motors will be 480 volt, and these lines are marked line 1, line 2, line 3. What we're looking at here, by the way, is a symbol of a transformer. So the line voltage comes in and it runs the motor, and the motor is 3-phase and 480 volts, but the controls are not 3-phase, they're single-phase, and they are 120 volts. So we have a transformer in our circuit that steps down the voltage. It's a step-down transformer, and it takes the line voltage from 480 volts down to our control voltage of 120 volts. The National Electric Code has a lot to say about what size the wires must be, the conductors, and what type of insulation you must use. And we won't go into that here, but just know that's a big part of the electrical code. The load is the thing that uses power from the line or from the controls to do work. So the motor is a load, this light bulb is a load, and so forth. Control devices start and stop the current, and they're usually some kind of switch. What we're looking at here on the right is a photo of a panel, motor control panel, that has a whole row of push-button switches, and they are going to control, see these wires here? They are going to control motors on this JCI crushing plant. Basic idea of a switch is it's got contacts, and you can open the contacts to turn something off, close the contacts to turn something on. So there are contacts, and then there's the operator, the thing that operates the switch. And in this simple example, it's a simple old knife switch where the knife blade comes down and makes contact. This example will help you think about push buttons in the ladder diagrams that we're going to look at. You can think about how when the switch is open, no current can get through because nothing is making contact. When the switch is closed, current can get through. We are required to have protection devices that will break the circuit either because we need to or we want to, or because something bad has happened like an overload and we need to break the circuit. And one of the questions in our assignment says, what are the 3 types of protection devices? Here they are: disconnects, breakers, and fuses. And they do 2 kinds of things. One, we might want to disconnect ourselves. And so here is that panel from JCI, and there is a disconnect switch right there. We can also disconnect power with a breaker, and you may have done that in the panel in your apartment or your house. Then the other kind of protection device is either a fuse or a breaker that protects the circuit from getting too hot. So there may be too much current flowing through and things are going to get hot. Or there might be a short circuit and things are going to get hot. In either case, as you see in this explanation up in the corner, too much current or a short will cause temperature to rise. It'll get hot. And if it's a fuse is a one-time use. So in a fuse, there's a metal strip that melts and that opens the circuit. Then you have to replace the fuse. In a breaker, there are 2 different kinds of metal that expand at different rates, and they expand, they open the breaker, and then you can come along and reset that breaker. So now we've got everything we need to make a complete circuit, and in the next 2 lectures we will look at how does all this stuff work, our power source, going through our conductors, going through our control devices, our switches, our protection devices with our overloads and our breakers. How does this all work?